Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 17 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3003. Maximize the number of partitions after operations. So let's read the problem statement. You are given a string s and integer k. First, you are allowed to change at most one index in S to another lowercase English letter, right? So here to change at most one index. So that simply means we can change one index or we can leave it as it is, right? So simply means less than equal to one. You are allowed to change at most. At most means at most one means 0 or 1, right? At most, this is the meaning of this at most word. You are allowed to change at most one index, so you can change 0 number of indexes or you can change one number of index, right, in S to another lowercase English letter. After that, do the following partitioning operation until S is empty. First, we have to choose the longest prefix of S, right? So first preference is the longest prefix of S, right? Containing at most K. Again, at most K distinct character means K distinct character or less than equal to K, less than K, right? So that's the simple meaning of this, right? We have to choose the longest prefix of S, right? This is going to be our first preference, right? And that longest prefix of S, it can contain K number of distinct characters or less than K distinct characters, right? But if it is possible, right, so we have to choose the longest only. That is our first preference, right? Okay, so here let's say your K value is 2, right? So if K value is 2, so here if we have string like this A, B, C, D, something like that, right? So now here two distinct character, here also we have two distinct characters. So and if I use this, right, then we have three distinct character. But if K value is 2, so definitely I'm going to choose this one, right, because we have to choose the longest prefix of S containing the at most K distinct character. But if my string is like this only A, let's say, and K is equal to 2, then I have to choose it, right? So we are choosing the longest only here, right, even though size is not equal to K, right? So we have to choose the longest prefix of S containing at most K less than equal to K distinct characters, right? So this is the longest only, right? So it's not like the size is not 2, so let's leave it. It's not like that. So if only this one is remaining, let's say in my string, and K is equal to 2, so we are going to choose it and we are going to delete it, okay, if question asks for that. Okay, so now here after that, if you see, delete the prefix from S. Okay, so here we have to delete the prefix from S and increase the number of partitions by 1, right? The remaining characters, if any, in S maintain their initial order, right? So the remaining characters in S maintain their initial order. Okay, so we have to turn an integer denoting the maximum number of resulting partitions after the operations by optimally choosing at most one index to change. At most one index less than equal to 1 simply means at most one index to change, right? So here, see this example number 1. These are the constants. Constant size is very large, as total length from 1 to 10 to the power 4, and as consists of only of lowercase English letters, and K values from 1 to 26. Okay, so here if you see this string, so this is string, we have A, C, 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 A. So here until here only one distinct character is there. Until here two distinct characters are there, A and C. Until here also two distinct characters, A, C, C, two only. Until here also two distinct characters, right? And until here also two distinct characters, right? A in the complete string, only A and C are the distinct characters, right? So K is equal to 2, right? So here there is only one partition, right? We have to choose the longest string, right? We have to choose the longest prefix of S containing at most K distinct characters, right? So we choose it completely, right? We choose this complete as one prefix of S, right? And then I'm going to delete this prefix from S, right, this line, and then increase the number of partition by 1. Initially partition, let's say 0, now I'm going to make it 1. The remaining characters in S, if any, we have to maintain their initial order, but my S becomes empty, right, if I choose this complete as prefix. So in that case my output is going to be 1, but here if you see output is 3. Reason is because of this word. Which word? This maximum. We have to turn the maximum number of resulting partitions after the operation by optimally choosing at most one index to change. Okay, so now in this case what I'm going to do, so here A, C, and here if this character I change, okay, let's take the same example, S of 2 to something other than A and C. So let's say I use Z here, right, and then here C, A. So now here if I choose this as one prefix, right, so distinct characters here 2. If I choose this complete, then there are 3, right? I can't choose this. I have to choose at most k, right? So if I choose this, let's delete it. So if I delete it, then partition is going to become 1. That's not what AC. AC is one partition. Now my remaining string is like this. We have to maintain the order. Now in this also, if I choose this first 2, right? So distinct characters is 2, right? So let's delete them. Now number of partition become 2 and my remaining is A, right? So now again, if you see this, so now that's why I have expanded this part, right? This part, k is equal to 2 and A, right? So here if you see, k is equal to 2, but only we have 1, right? So only one distinct character, that's it. Okay, so I'm going to take it, I'm going to delete it, I'm going to add it here, and my s is going to become empty. So now my string becomes empty, and here how many partitions I did? I did 3 partitions: AC, this ZC, and this A, right? So let's read the problem statement now, this explanation now. The optimal way is to change S2 to something other than A and C. For example, B. Then it becomes AC, BC. In our case, we take Z, no issues. Then we perform the operation. The longest prefix containing at most 2 distinct characters is AC. We remove it and S becomes a BCA. Now the longest prefix containing at most 2 distinct characters is BC. So we remove it and S becomes A. Finally, we remove A and S becomes empty. So the procedure ends. Doing the operation, the string is divided into 3 partitions. So the answer is 3. That's it. Clear? We have to choose the longest prefix of S containing at most k distinct characters, delete the prefix sum from S, increase the number of partitions by 1. The remaining characters, if any, in S maintain their initial order, right? And we have to do this following partitioning operation until S is empty, right? That's it. And you are allowed to change at most one index in S to another lowercase English letter. That's it. Okay. Now see here, example number 2. So this is my string, right? A, B, B, right? K is equal to 3. But right now, if you see, only 2 distinct characters are there, A and B, okay? Until this index, only 1 distinct character. Until this index, only 1. Until this index, 2 distinct characters, A and B. Until this, 2 distinct characters. Until this, 2 distinct characters. Until this, 2 distinct characters. Now, here, K is equal to 3, right? But here, if you see, this line, uh, after the operator by optimally choosing at most 1. Only one index you can change. You can change 0 or one number of indexes, right? Less than equal to 1, right? So here, if you see, let's say if I change any of these, let's say right now total distinct character is 2. Let's say I change this to Z. So now again, if you see again this completely, so 1 1 2 3 3 3, this is what you are seeing, right? Until this index 1 distinct character, until this we have 3 now, right? But overall distinct character is still 3. Now it becomes 3. Previously it was 2. Now it's 3. And k is equal to 3. So at most we can take until this only, right? So in one go, I'm going to take this complete string and I'm going to delete this. I'm going to take this complete prefix and I'm going to delete it, right? So here, if you see, initially S contains 2 distinct characters. So whichever character we change, it will contain at most 3 distinct characters. So the longest prefix with at most 3 distinct characters would always be all of it, this complete string. Therefore, the answer is 1, right? That's it. I'm going to delete this completely in one go and my S is going to become empty. Output is 1. That's it. Right? Clear? Now see this example number 3. Okay, so S is nothing but X, X, Y, Z and K is equal to 1. Right? So K is equal to 1, right? So here X and X, Y and Z. So until here, if you see now, 1 1 and here 2 and here 3, right? So k is equal to 1. So one longest is this one, right? So that simply means this is 1 I'm doing, then here one longest is just y, then one longest is z. So like this. So your output is not 3, right? Because we need to return the maximum. So what I'm going to do here, instead of this x, I'm going to write a, let's say. So x1 a y z, right? Like this. So here this is 1, this is 1, this is 1, this is 1, total 4, right? Because we have to turn the maximum. The optimum way is to change S0 or S1 to something other than the characters in S. For example, to change S of 0 to W, alright? Then S becomes this W, X, Y, Z, which consists of 4 distinct characters. So as k is equal to 1, it will divide into 4 partitions. We need to increase the number of partitions, right? So I hope that you guys are clear with the examples and the problem statement. So now I'm going to show you the brute force to solve this problem. Right? So first let's understand how this brute force comes to my mind. Okay, so here let's take this example, or this, let's take this example, a 3c and a. Okay, so a 3c, then we have a, okay, and k value is 2, right? So now here, if you see, how many number of partitions I can do if I don't make any change, right? So here number of distinct characters until this index is 1. These are the indexing, right? 0 1 2 3 4. Number of distinct characters until this index I. is nothing but 2, right? Clear? Number of distinct character until this index is 2, right? Same way I'm going to fill rest, right? Let me just make it, remove it, 2 and here 2, right? So now here, see, overall if you see, we need at most k, right? So less than equal to k. So here we still didn't cross 2, we are still seeing 2 only, right, until here. So I can take this complete string in one go, right? And I can take it as a prefix and I can delete it. So the partitioning, number of partition here is nothing but 1, right? This is clear, right? A C C C A, I'm going to take this completely as my prefix, I'm going to delete it, my s is going to become empty, and number of partition in the end is just a 1, right? Okay, this is done, right? So here I'm not making any changes. So how many number of indexes I can change? I can change less than equal to 1 number of indexing, right? Okay, so now here if you see, this is my string, right? A C C C A, this is what I have, right? So indexing 0 1 2 3 4. Okay, so now here let's pick this index, right? So now here in this place, we have A. So if I write B, then what is going to happen if I write B here? So then I'm going to get something like this, B C C C A. So number of distinct character 1 2 2 2, and now here if I see, this is a third distinct character, right? So I can do one partitioning here, right? I can do one partition here because we need to do at most k partitions, right? So if I do one partitioning here, so let's see this next partition. Okay, this is one partition, right? So here A is occurring for one time, right? A is a new partition. I'm going to start from here, right? This is one partition and this is a new partition I'm going to start, because in one partition we can have at most k, right? So number of partitioning in this case is nothing but 2, and those two are nothing but B C C C, and one is A. That's it. So total number of partitioning is nothing but this one and this one, total 2, right? In this case it was complete, if I don't change any index, because in this complete we have two distinct characters, right? Two distinct characters, right? So only one partitioning we have, but here we have two distinct partitionings, right? Two different partitionings. Here also at most k, right? And here also at most k, we didn't cross more than k, right? So this is the, so here with B, if I see, now let's suppose if instead of B at this particular index, if I use C, then what is going to happen? Then my string is going to like this, C C C C A. So 1 1 1 1 and 2, right? So here overall I can take this as 1, right? And the number of partition in this case is also going to be 1, right? Because here at most k distinct characters we have, right? So this complete. So with B I am getting 2 partition, with C I am getting only 1 partition. Same way I have to try with D, E, F until Z, right? Until Z I have to do, and I have to calculate the number of partitions that I'm going to get. So only one index I can change, right? So this is for 0. Next time I'm going to take this original string again, and I'm going to pick this index, and here instead of C I'm going to try all the combination A B C D E F G until Z, and I'm going to calculate the number of partitions. Then next time I'm going to choose this, and here I'm going to choose all the distinct character A to Z, and then I'm calculating the number of partitions. Then choose this, then here A to Z, total number of partitions, then choose this, then here A to Z, total number of partitions we are going to get. In the end we have to return the maximum number of partitions, right? The max number of partitions, that's going to be my output, right? So if you see in this brute force, right? So one is the base case that I'm checking here, in which I'm not changing anything. Then I'm calculating number of partitions, right? Then after that I'm picking one index, and at this index we have 26 choices, right? We have 26 choices. Then for this 26 choices I'm calculating the number of partitions over this complete string, total n times, right? Right? For this index we have 26 choices, and for those 26 choices I'm iterating over the complete string of size n to check the number of partitions, right? So this is what I'm doing, right? And here this is just for one index, then I have to do this for this index, then I have to do this for this index, then I have to do this for this index, then in the end I have to choose this index. For this index also 26 into n choices we have, right? So we have to do this for total n, all the factors. So my time complexity here 26 into n square. So n value here, the length of this string is 10 to the power 4 in our constants. So it's going to become 10 raised to the power 8. So very big, right? So this is bad, right? So we are going to get the time limit exceed error using the brute force. Let's see. Let's see here if you see this, and let's see the code. So here if you see 270 test cases got passed out of 277, right? But we stuck with this issue, time limit exceed error. So here what I'm doing, so this is your main method, right, in which you have string s and k. So this base case when there is no change, so in the base is equal to count the number of partitions in s and k. So how I'm going to calculate the partitions? So if you see this example we have, right, a c c c a, right? So in this I'm passing the string s and I'm passing the k, right, and I'm calculating the total partitions. So frequency is 26 because we have characters from a to z. I have to calculate the frequencies of all these, right? Distinct is 0, right? So then I'm iterating over all the characters in my string one by one, and if frequency this a is occurring for very first time, right, frequency of a is 0, then distinct character is 1, right, and I'm increasing the frequency of a to 1. Then after that we have c is occurring very first time, so distinct plus plus, so distinct value is going to become 2, right? This is nothing but distinct value. Then after that c is again occurring, right? So c frequency is 1. Then here this frequency is not 0, right? Niche c frequency when I'm here, because c frequency was already 1, right? So distinct I'm not going to increment. So frequency of here c frequency is going to become 2, then 3, right? And here also 2 same, distinct will remain same, here also 2 will remain same, but a is going to become 2. So here if you see this base case, right, if distinct is greater than k, so distinct is 2 is greater than 2, no, we never reached here, right? So in the end I'm just returning partitions plus 1. So partitions in each count is 0, 0 plus 1, 1. So I can take this complete as one partition, right? So that's the meaning of this. So this is how my count partition is going to work, right? So now let's say if I have this something like this, right, then what is going to happen? A and c, okay, a is one time, c is one time, and b is occurring one time, right? So if b is occurring one time, right, my distinct here, if you see first this base condition, if you see distinct is going to be incremented, distinct is going to become 3 here for this c, right, for this b, right, for this b distinct is going to become 3, right, because a is one time, a is 0, then distinct plus plus, c is 0 initially, then distinct plus plus, now b is 0, then distinct plus plus, it is going to become 3, this b, right? So now distinct is 3 and 3 is greater than 2, yes. So now partitioning is going to become 1, partition is going to become, then again I'm going to fill the frequencies of all these characters to 0, a to z. The reason is because I'm going to separate it out, right? So again I'm going to make it 0, and then here frequency of c minus a, this b, right, this b is the beginning. So for this particular character I'm setting frequency to 1 again, so b is equal to 1 and distinct is equal to 1. So for this I'm changing it back to 1, right? Same way for b, then c, right, two distinct characters, right, because I'm picking this now and frequency is already 0 of c, right, here. So c is 2, right, and then a is here, it's going to become 3. So as soon as it becomes 3, so I'm going to break it out also by c, so it is going to remove, and for this a frequency is going to become 1 again, this also reset to 0, right, and frequency of this is going to become 1 and distinct is going to become 1, right? So in the complete string, right, when we iterate over this char array, we did 2 partitions, and in the end I'm returning partitions plus 1, so overall 3. So those 3 are nothing but a c, b c and a, right? That's it. Clear? Done. So this is how it is going to work, right? So here this is the answer that I have returned. I am setting it to base value that we have calculated here. Then we are going to try changing each character, right? So this is going to run off n time. Then original array, I'm going to take all the choices, 26 choices we have. Then for all these 26 choices, I'm going to call this count partitions, which is also iterating of n number of times, right? Okay, so here this is what I'm doing, right? If character is original, right, a to a I don't want to change, so that is why I'm continuing, and then I'm just going to calculate the max value answer and the number of partitions with this change, and I'm again reverting the array to back because only one change we can do at most, right? And base with no change we have already calculated. In the end we are just returning the max of answer, that's it. So overall time complexity is of and square to 26, that is why we are getting time limit exceed error. Okay, so this is the brute force. Okay, now let's see the optimal approach to solve this problem now. Okay, optimal approach. Okay, let's see that. All right, so now what you need to do, so let's take the same example only. So we have a c c c and a, right? 0 index, 1 index, 2 index, 3 index, 4 index, and what is the value of k? K value is nothing but 2. All right. Okay, so this is nothing but your string s, right? So in brute force, if you notice, for first at one index we have 26 choices, right? And for those 26 choices I have to calculate the number of partitions by iterating over complete string, right? And once I do that, so I have to do the same thing for all the indexes, right? Total n. So total length of my string, right? So this is what we were doing, right? Again and again we are calculating everything. So now this time in optimal approach, I want to store this information, right? So let's suppose if I'm here, so I want to have information until here and I want to have some information until here, right? So I want to store information until this part from my left side, right? And I also want to have some information in this right side, right? So here what I'm going to do, I'm going to create two 2D arrays, left and right suffix, and in those arrays for all the indexes, for all these indexes, I'm going to store total three type of informations. One is the number of partitions till here, number of partitions till here, right? This is one information that I'm going to store at all these indexing one by one, right? I'm going to pre-calculate all these things. Then I'm going to store the bit mask of distinct, right? So this I will discuss now, right? After this point. And third is count of distinct, number of distinct. Okay, so these three things I will store information, right? So what is this bit mask of distinct, right? So I'm going to show a like this. So we have this 0 0 0 0 1. Okay, I'm going to take this is nothing but 1, right? I'm going to left shift this 1 with the indexing of a. So we have these many indexes a, b, c until z, right? A is at 0 index, b is at 1 index, c is at 2 index, z is at 25 index. So 1, and if I do the left shift of 1, right? 1 left shift, a is 0, right? So 0 times. So that simply means this is nothing but a only. How I'm going to show b in bits? So 1 left shift 1 time. So that simply means 0 0 0 0 0 0 1 0. So this is how I'm going to show the b. And how I'm going to show c? C means 1 left shift, c is at 2 index. So here 2, 1 left shift 2 means 1 and 2. Okay, 1 I'm left shifting 2 times. So 0 0 1 0 0. This is how I'm going to show c. Same way how I'm going to show d, I'm going to show d like this. Okay, same way we have to do until z, right? So in z we will see 1 somewhere here, then something like this. Okay, in the end something like this. So for this a, this is 1, right? At this 1 position, at this 2 position, let's say 3 positions, 4 position, right? Same way this is at 26. If you want to start it from 0, then this will be at 25. Okay, this is just for representation purpose, right? So now this is nothing but this bits, right? In bits type, bits form I'm writing all this, right? So now what is the benefit of this? What is the benefit of this? Okay, so now here let's say if you have this a, right? If you have string like this a, right? For this a you have this, right? Clear? Okay, now next time again this a comes, let's say. So again this a comes, right? Now if you do the AND of these two, if you do the AND of these two, so what is the value you are going to get? You're going to get something like this, right? 0 0 1, right? This value is not 0, right? This is not 0, right? So if you have a in the past and this time you get something new, not a again, something new, c. So see how you're going to write? You're going to write like this. So now if you do the AND of this, you're going to get 0. So this value is 0, this value is 0. Okay, so now here one benefit is this. Okay, so if we are getting some duplicate, we are going to get the non-zero value here, right? But if we don't get any duplicate, right? If we get 0, complete 0, that simply means this time there is a new value, right? This is one benefit. Okay, one benefit of this, right? And here if I have a and b, okay, a I'm going to show it like this, b I'm going to show like this, and if I do the OR of this, okay, OR of these two, so I'm going to get something like this. So what does this mean? What does this mean? This means that a is set and b is also set, right? And now here if you count the number of set bits in this, number of set bits is 2. That simply means 2 is nothing but the number of distinct characters. Okay, these are the basics. Number of set bits is nothing but 2 if 2 bits are set here, right? Okay, next time let's suppose c is coming and I'm going to let's suppose b is coming. If I do the AND, okay, if I'm checking if this character is already there, then we have to do the AND. So b I'm writing like this. So now this time see we are getting some non-zero, so that means b is already there. So AND benefit, OR benefit we are maintaining, right? What are the characters we have seen, right? Now let's suppose in case we have a, b, C, D, everything. Then all the bits are set. All the bits are set, right? All the 26 bits are set, right? In that case, right? Okay, so all the 26 bits are set, right? So in this side, let's suppose 26 bits are set, all the 26 bits set, right? In this side, all the 26 bits set, 26 bits set, right? In just like this example here, all the 26 bits set, 26 bits set, all the 26. Now in this side, if I do any changes, so if I combine these two, so again here also 26, here also 26, so all the 26 26 same only, right? A to Z set here, A to Z set here, then simply means A to Z are set only, right? Here we have AB, here we have AB. When I merge these two, then still we have AB only, right? Same way, here we have AB to Z, here we have AB to Z, overall we have AB to Z, right? So if overall we have AB to Z, so here can I use any distinct character which is there and which is not there, which is not there? So if everything is set, then I can't use any other character, right? Okay, all right, see like this. Here we have AC, here in this side we have AC. Let me use some other pen. Here we have AC, here also we have AC. Then in this side, if I merge these two, that simply means that something like this I will get A, B, C, something like this. Now here in this side, if I use C only, then again overall, okay, if I combine everything again, I'm going to get 101 only, right? Overall, right? Because only A and C. So here I don't want to use C, I want to use something else, right? I want to use D, E, because D and E are not used here. So instead of checking like D and E, I will just check now that I want to find out the values. If I merge these two, all the common bits will be set. All the common bits, not all the bits are set, right? Here if we have A, B, Z, and here we have A, C, D, right? If I merge it, then what will happen? A bit is going to set, B, C, D, Z, all these are set, right? Overall 5 are set. So if overall 5 are set, and here we have total 26 options, right? A to Z. So if 5 are set overall, if I combine this part, that simply means that here I can use something else, right? I can use something else. So I will just see if I have option to use something else. Okay, we will discuss this further, but that's what I'm saying, right? Overall combined ABZ ACD, overall combined we are getting ABCD so 5 set. So here over 27, but here also if 26 set, here also 26 set, then we are not going to get any distinct here, right? So this things is going to help us in this, right? Something like this, right? So now let's see how I'm going to solve this problem. Okay, so we are going to do the dry run. Okay, so let's take the example. This is what we have: A, C, 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 A. This is my string, right? And K value is 2, right? I'm going to create one left here, left 2D array, right? This is nothing but index 0, index 1, index 2, index 3, index 4, and here, okay, and here let me use this box, okay, for left, and here we have to fill all this information in this, okay, one by one. So here this particular box, right? This particular box, so this is going to store the state for this one until here, right? Perfect sum is like this only, right? Perfect sum. So if I'm storing something like this, that simply means until here whatever the information, for this until here whatever the information we have, for this in this box I'm going to store until here, in this box I'm going to store until here, right? So what I'm going to do here, initially my I is here, right? Initially my I is here. Okay, when my I is here, so we have only A, right? Only A, right? So this is the new character, right? This A is the new character, right? Distinct, right? So in that case, I'm going to make the distinct value, right? Distinct value as 1. Okay, initially it is 0 only, and mask value, so mask value I'm going to set it to 001, right? Clear? That simply means only A we have, right? And this is done. And what else we are filling? We are filling the partitions, right? So partitions is still 0, right? So when we are incrementing the partition, when my distinct value is becoming greater than this K, right, only then we are operating partition, right? So here also same thing, P is equal to 0, mask is, I can say 101, right? Because we have distinct character A and C, and distinct is 2. Same way here, partition is equal to 0, mask is nothing but 101 only, because we have distinct character E and C, and distinct is 2, right? And here also partition equal to 0, mask is equal to 101 because we have distinct character A and C and distinct values too. So this is how I'm going to fill everything, right? So we haven't exceeded anything yet, right? And here P is equal to 0, mask is equal to 0, D is equal to 0 at this initial by default, right? This is how it works. So first we have to build the prefix partition info. As we move from left to right, we keep track of how many partitions have been formed, the bit mask of the characters in the current segment, and how many distinct characters are in the ongoing segment, right? Clear? This is done. Same way, same thing you have to do for this right also, right? Okay, this is for suffix sum, right? Again, let's take the box. Okay, let's take this box, and now we have to fill everything here. Okay, this, and this. All right, so now here at this, right, at this I'm going to store the information until here. At this box I'm going to store the information until here at I plus I minus 1, right, until here. At this box I'm going to store information until here, right? So for this value, I'm going to store the information in I minus 1 box. For this value I'm going to store the information starting from this at I minus 1 box. For this information I'm going to store in I minus 1 box. For this I minus 1 previous box now. Here if you see, for this I plus 1, this I plus 1, right? And here I minus 1. Okay, so let's fill all these values again one more, right? So here now this time we have to move from right to left. Okay, so here we have only A, so partition is equal to 0, mask is nothing but 0 0 1 because we have A only, and distinct is nothing but 1, right? Same way here partition is equal to 0, mask is 101 because we have A and C, and distinct is 2, right? And here partition is equal to 0, mask is 101 because we have A and C, and distinct is equal to 2. Here also partition is equal to 0, mask is equal to 101 because we have A and C, and distinct is nothing but 2. And here partition is equal to 0, m is equal to 0 because we have nothing, and distinct is equal to 0, right? This is done. Now this part is done, right? Clear? Okay, now we have to combine the left and right. Now you will see the magic, what is going to happen. Okay, so now here let's do one thing. Let's first let's start with this only, right? Let's see this only first, right? What is going to happen here? Okay, so now here at this particular position. Okay, so now here if you see, let me just minimize something. Okay, now if you see here, all right, so here for this one, right, in the left side, right, for this, if the left side if you see, we have how many number of partitions and everything we have to check. Okay, so first for this position we have something here, we have something here, right? So this box itself contains the information of this side, right, this side, and this box itself here, it contains the information of this side also, right? So we are good, right? This box only we need to check. Okay, now in this box, that is a benefit, that is why I was taking like this. Okay, so now total basic segments from left and right side. Okay, so now the total number of segments is nothing but, I'm going to create one variable int total, and I'm going to say it's nothing but left and I comma 0, I comma 0. So add this I comma 0 per partitions we are storing 0 number of partitions. Same way here right and here I comma 0, that's means this 0, right? And we are doing here plus 2. The reason is this one and this one, right? So we are causing these to separate, and now we have to make sure the changes, right, the number of changes that we need to do after this. So this is nothing but a basic segment initially. So left side, right side, so here these two sides are there, so I'm writing 2. Okay, done. Clear? This is 1, this is 1, right? Okay, so I'm considering them as different. Okay, I'm considering this is 1 and I'm considering this as 1. Okay, that is why I'm writing here 2. All right, now if I combine these two, so here if you see, combine, if I'm combining these two, we have mask value here and mask value here. So combining means A and B combined, right? If I combine A and B, so A I'm writing like this, B I'm writing like this. So if we combine means OR. So if I combine, I'm going to get something like this, right? So here we have 101 101, right? So here int combined mask is nothing but, here you can say left of I comma 1 and here right of I comma 1, right? So you are going to get 101 only, right? So this is nothing combined mask, and this combined distinct is very simple. Int combined distinct, right? Distinct means left of this you can do, or no, instead of this now combined distinct now, so this is combined mask. So here you can use this now integer of bit count of this combined mask value from above. So you are going to get the total number of set bits, right? Okay, now once this is done, once you have calculated this, so your total is coming out as 2. Combined mask is going to come as 101 because we have AC here, also AC, and combined distinct is 2, right? Combined distinct is 2, mask is this, and total is this. Okay, now here in this you have multiple choices, right? So here if you see in the information, k value is nothing but 2, right? K value is nothing but 2, right? So distinct is 2, that is nothing but until this side, right? Distinct is 2 in this part, distinct is 2 in this side, distinct is 2, right? So I'm taking this as one partition, I'm taking this as one partition, right? I'm considering them as separate. Now why I'm considering them separate? Because here I'm planning to use something which will create the partition, which will help in creating the partition, right? How it is going to create the help in partition, let's see that. Okay, so here in this side, this is 2, this is 2, this is also equal to k value, right? This is also equal to k value. Now here if in this side, right, so combined distinct here, combined distinct comes out as 2, right? Right, and in total we have 26 alphabet characters, a to z, a to z. Only distinct is 2 means only 2 are set, means we have 24 other choices, right? 24 other choices. So if I choose any other choice, any other than, we have some choices, right? That's what we have to turn the maximum. So definitely I have to go with some choice here, right? We have to turn the maximum number of partition. Definitely I'm going to choose some character which is not here, which is not here. So let's say I use that. So if I use that, then what I'm going to do, if this is the case, right? What I'm saying, if left of I2, right, number of distinct values, if it is equal to k, and right value, right, I comma 2, if this value is also equal to k, and here I'm going to write combined distinct values is less than 26, then in that case just increment total plus plus, right? So total plus plus, right? This this is clear, right? Very simple, right? Here I have two parts, right? In this we have two distinct characters, in this also we have two distinct characters, right? Here I am trying to use something which is not here, which is not here, combined, right? So here, so total number of partitions are 3 only then, right? Here if it's both equal to k, right? If this is the case, else if here the minimum of math dot min of combined distinct plus 1, combined distinct, okay, combined distinct, and in that if I add 1, right, over the 26, right, if this value comes out less than equal to k, then in that case I have to do total minus minus. What is this mean? Let's say this is for k is equal to 2. Let's say my k value is 3, right? We have AC, this value is 2, and here AC, this value is also 2, right? Now here if I use any value, right, if I use d here, right, so combined distinct overall is going to become 3 only, right? In this case 3 is less than equal to this k, right? So total, previously total was what? Total was 2 initially I was taking, right? How total we are calculating total? We are calculating total like this, left side, right side, and considering them as different, that's why I'm writing plus 2. So now from this total if I subtract 1, I will get 1, right? And this one is right now because here in this AC we have only one distinct, only 3 distinct vectors which is equal to k. So we can take them as one go, take them in one go, and we can remove it. So that is why I'm writing like this, okay? And max number of partitions, nothing but the number of max partitions, and a total, whatever the total value, we are going to do step by step, okay, like this. So this is what I'm planning to do here. So very simple here, right? If I write the code, then you guys will get better understanding, okay? So my total is considering them as 2 different, and then this is base, okay, base case 2 different, and here's something I'm trying to use something, okay, at this particular index. I have to do the same thing for this one, okay? Here also, what is here, and I'm considering them as different. And if this is value equal to k, this value this side value equal to k, then in that case total plus plus. If there is choice to just do some other character, but if there is no choice, right, and here the value combined value comes out to be less than equal to k, then we have to do the some addition, right? So here this is one case. Let me show you the dry run, complete dry run of a few examples. So I think I have, yeah. So here, if you see this is your example number one. So here also, if you see what we are doing, we are building the left prefix information first, then we are building a right suffix information, then we are combining left and right. So we have to check for all the indexing one by one, right? So here, if you see, at index 0 character A we have, right? So left side partition distinct mask, right side partition distinct and mask we have to check, right? And then combined distinct is this, then total partitions after change is going to be 2, right? Okay, so at this we have to check, right? So total means this side, so 0 0 and overall total segment 2, so that is why I'm taking it as 2, right? And then that's it. Okay, that's it here. So total partitions after change is 2, right? So here, if you just notice like this, now we before this, if you are here before this, you have 0, right? And the partition 0, distinct is also 0, mask is also 0, right? And if you see the right side, okay, this part, so A and C means 101, partition is still 0, distinct is 2, right? So that is what you are seeing here, distinct 2 and mask is, okay, this is done. Now if you combine these two, so again, if you combine only A and C, we have, right? So combined distinct is also 2, and the base total means the left segment is 0 partition, right side 0 partition plus 2 total number of segments, right, left and right. So I'm considering them as different, right? 0 here, and inside this is another I index. Okay, so before that and here, right? Now we have choices. Okay, so overall G2 only, so that is why base total. Now after that, if you see here in this side distinct is 0, here this side distinct is 2, right? This is what we have, right, left. So second condition is total minus minus, right? That's what we were doing, right? So first, how we are calculating the total? So total, how we are doing the calculation of total? So this side the partition is 0, this side partition is 0, right? And overall 2, this is what we are getting here 2. And once I get that, then total distinct is total, this is what we are doing. And that's it, right? Total partitions after change, if you still do that, so in that case you are going to get what you are going to get, at most 2 only, right? Why 2? Because here C A, this part is fixed, only this part we are changing now. So instead of A, I can use B here, then also this is one partition, right? So overall total 2 partitions you are going to get, right? That's what. Okay, same way at index group 1 you have to check, index 2 you have to check, at index 3 you have to check, at index 4 you have to check, then wherever you are going to get a max, right? So 3 is a max, right? So that's what you are going to find answer. That's it. Okay, so both full can create here, if you see this line, both full can create the extra partition, then we are doing a plus 1, right? Okay, but here extra partition full we are not able to create. Reason is we didn't do total minus minus also, right? Here in the code, right, if you see this part here, this code, right? So here this condition is also not valid at index is equal to 0, right? Because in the left side we have 0, in the right side we have 2, right? So these are valid, and this first condition itself is not valid, so we move to this else if. So in the else if also, you see combined distinct plus 1 we are doing. So combined distinct is 2 and CCA, right? 2, and if I do add 1, okay, so it is going to become 3, and here 26. So minimum is 3 is less than equal to k, no, right? So we are not doing total minus minus, so overall total value will remain total only, right? So that is why we are not doing total minus minus here, right, in this case, but simply we are writing 2. So this is clear, right? Same way at index 1 we have to check all that stuff, right? Here we are doing plus 1 because at index 2 this is already clear, right? A, C and C, A. So here we are doing plus 1 because using any extra factor will lead to a formation, right? Here 2, here 2, so here any new means something new you will get, right? So this I already discussed. Okay, so this you can go over it. Same way this is for, I think, example number 2, I think so, right? So this is my string and case to 3. Then again you have to build the left prefix information, right prefix information. Then once you do this, then you have to just iterate over all the next one time only. So left and right combined you have to do. If with the merge of partition, we are doing -1 here, overall. Why? So let's see this. So here add this index 0, right? Before that we have something, add this we have something, and add this we have something, right? So add this we have a b a a b, this we are not changing, and here we have nothing, right? So here if you see in this partition, how many partitions we can form? We can form 0 partition, right? Because case 3 we need, so only 2 is there. Here also partition 0. So overall it comes out as 2 only, right? In the base total is 2 only, right? Okay, and these are the mask values. So here 0 1 only, and here 0. So this is done. This thing is 2 this side. Okay, this is done, right? This part is clear, right? Combined also is clear, right? Now if I merge this partition, right? So here if you use a b a a b, right? Here if you use some other vector c, right? So in that case, in overall, if you see, the distinct is 3 and which is equal to k. So if this is the case, right, less than equal to k, right, then we are doing total minus minus. So that is why here minus. So what? Because in one go I can remove it completely. That is why we are not doing minus. So same way you have to do index 1, index 2, index 3, right? So from this example, this part is clear when we are doing minus 1, right? From this part you are clear when we are doing plus 1, and you are also clear when we are not doing anything minus 1 or plus, right? So that's it pretty much, right? Now let's write the code. That's it. Okay, so code is going to be very simple. Now I'm going to write the same story that I've explained. Okay, let's not waste much time here. So here first thing what you need to do, first calculate the length of string. So s dot length, right? And then after that, left of I is nothing but the number of partitions. Still here we have to store bit mask of distinct and count of distinct, all that stuff, right? So here int left is nothing but new int, and here n3, right? And then we have to store right of I same as our left of I, but from the right side we have to do, right? In that case, in this case, so here I'm just going to write right new int, and here n comma 3, right? And then we have to, step 1 is build prefix partition info. As we move left to right, we keep track of how many partitions have been formed, the bit mask of the characters in the current segment, and how many distinct characters are in the ongoing segment, right? All that stuff. So int partitions is equal to 0, int mask is equal to 0, int distinct is equal to 0, right? So mask is 0, nothing but bit mask of current segments characters, and distinct 0 means number of distinct characters in the current segment, right? Now here int I is equal to 0, I is less than n minus 1 only we have to do, and here I plus plus, right? And here first we have to calculate bit as nothing but 1, and left shift s dot char at index I minus a, right? And if there is a new character for this segment, then what, how we need to check? If mask, right, the mask value, and I'm just going to do the and with bit. Okay, so if this value comes out to be equal to 0, right, that simply means new character, right? So in that case, distinct plus plus, and here I'm going to check one more thing. If distinct value is less than equal to k, right? So in that case, what we need to do, in that one combination we have to form, right? So we have to do the OR. So mask is nothing but mask OR with bit, right? This is what we need to do, right? And here, if this is not the case, then we have simply means we have exceeded the k value, then we have to start a new partition. So here partition plus plus mask is equal to bit I'm going to set, and distinct I'm going to set it to 1. Okay, so this is done here, right? Okay, now we have to store the state at I plus 1. So here at I plus 1 we have to store, okay, I plus 1 and 0. So this is nothing but partition value, and at left of I plus 1 and here 1 we have to store mask, and here left I plus 1 and here 2 we have to store distinct. Same thing I have explained, right? Same thing I have explained in the code as well. Here if you see three things we are writing, right? Everything. So when I was checking here, so this value is storing this side, this value is storing this side. So that's what. Okay, clear. So this is done. So here this for loop ends, right? So this is for left side. Now step 2 is for the right side. So again, for the right side, again, partitions I'm going to set it to 0, mask I'm going to set it to 0, and distinct I'm going to set to 0, right? And then again we have to use the formula, but this time the same thing that we have applied about, but we have to move from right to left. So int I is equal to n minus 1, I is greater than 0, and I minus minus. And now inside this, what we need to do? So I can simply do one thing. I can copy this part, I can copy this also, and here distinct I have to operate now. So why I'm leaving it blank? So distinct is nothing but 1 I have to set. Okay, yes, that's it. Now here I need to write few things. Okay, so here in the right side, bit is nothing but 1, left it as dot character at I minus a. Good. This is also going to remain same, only distinct less than equal to k, mask this will remain same. And here instead of I plus 1, here we have to do I minus 1 everywhere. Here also I minus 1. And here instead of left I have to do right. Here also same thing, right. And here also we have to do the same thing, right. Clear? This is done. Okay, that's it. So this is where my this for loop ends. That's it. Okay, now we have to just combine. So very easy. Int max partitions. This code you already know. This code I have already written here. The same code I will write here, this part. Okay, so int max partitions equal to 0, and now here I'm going to run the loop. Int I is equal to 0, I is less than n, and here I plus plus. Now basic segments from left plus right sides, basic segments, right? Int total is nothing but left of. I will add this code with comments in GitHub. Okay, you can check the comments from there. All right, here right, and GitHub link will be there in my description of videos, right, for all the codes. And here you have to just do the 2, then combine mask and distinct count from both sides we have to calculate. So here int combined mask is nothing but left of I comma 1 plus right of I comma 2. Okay, I comma 1 only, right, because at this position we have mask value. And combined distinct is nothing but integer dot width count of combined mask value, right? Now after that, base condition, right? If left of I comma I2, if this value is equal to k. So what we are doing here, now we have to adjust total partition based on the possibility of changing s of I. So if both sides already have k distinct characters and combined is less than 26, then changing s of I could create an extra partition. That is why we are going to do +1. Otherwise, if combined distinct fit within k after one more character, then we might merge one partition -1. Okay, so that's what I'm going to do here. And right of I comma 2 if it is equal to k, and the combined distinct value, right, if this value is less than 26, then in that case just do total plus plus, else you have to do total minus minus. But if the math dot min of combined distinct +1, right, and overall 26, right, this value, okay, if this value is less than equal to k, right, in that case total minus minus. And in the end we have to return the max partitions as math dot max of max partitions, right, max partitions, and here total. That's it. And here in the end you have to return what total this max partitions, right? So return max partitions, that's it. Now let's run the code and see if the code issue. Will try to fix that. So see, line number 39, something is missing, right? Distinct is equal to 1. All right, so here also distinct 1. Okay, now let's run it. So here partitions, I think I'm using partitions, right? So here partitions plus plus s, use s here, and I think here also we need to change this partitions. Anything else? Left of I plus 1 partition. Okay, let's run it. Line. Okay, let's see, let's run it again and let's see. Okay, line number 21 also. 21, where is line 21? Okay, here also partitions. Think then I need to change here as well. Okay, let's run it again. So finally all the test cases has been accepted, right? Now let's submit it. Oh nice, so there is some issue. So let's see where we are getting this error. Okay, let me just maximize the screen. Okay, so see, issue is here, right? Combined mask. So we have to do the or, not add. This is a mask value, right? We have to do or. So now let's see. So now let's submit it. So see, finally this solution is also accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.